Okay, for this section, we're going to solve by completing the square. That's generally everybody's least favorite method to do quadratics, but it actually, if you complete the square on your standard looking quadratic equation, which is this, if you complete the square on this, it actually gives you the quadratic formula. So to complete the square, I have steps listed. If you look at the notes that are typed, there's steps listed. So step 1 is to make sure your leading coefficient's 1. So in this case, leading coefficient's the a, whatever's in front of the squared term. It has to be 1. That's already done for us. Step 2, unlock with factoring. With factoring, we want the right-hand side to be 0. With completing the square, you want to move your constant term over to the right-hand side. So we would actually have it look like, if we subtract c over, negative c there. So this case, we've got a minus 6, so we want to add it to both sides. So we're going to do y squared minus 5y is equal to 6. And then step 3 is you take half of this term and square it and add it to both sides. So half of your b, so we have negative 5 halves squared. And if you add something to the left-hand side, you have to also add it to the right-hand side. And the negative here doesn't really matter because when you square it, it's going to become positive. So I write it down just because it's there. And then that way you remember, if this is a negative in front of your, like where your b is in front of the variable to the first power, then you're going to have a minus. And if it's a positive, you're going to have a plus. So the reason when you square this, it's going to become a positive, so it doesn't matter. But if you write it down with a minus, that way you know that this goes into this slot here. So you're going to write it as y, and then we've got negative 5 halves, so we're going to do minus 5 halves all squared. So that goes here. If you had a positive in the parentheses, you'd have a plus here because you'd have a plus there. So I do it that way just so you remember to write down with a minus instead of a plus. And 6 plus, if we square this, 5 squared 25 and 2 squared is 4. And like I said, the negative goes away. So whatever you have in parentheses goes in this slot. And you can check it. You can multiply it back out. If you do y minus 5 halves times y minus 5 halves, it will give you y squared minus 5y, and then minus 5 halves times minus 5 halves is minus 5 halves squared. So it will give you this trinomial that you had. And then we have just add 6 and 25 fourths, which would be 49 fourths. So then step 5 is to get rid of a square. You take the square root of both sides. You have to remember on the right hand side though, you have to do plus or minus. So plus or minus the square root of 49 fourths. So if we simplify this square root of 49 is 7. Square root of 4 is 2, not 4. I said 4 and wrote it down. Square root of 4 is 2, so you'd have plus or minus 7 halves. So step 6 is solve for your variable. So add 5 halves to both sides. You have 5 halves plus or minus 7 halves. So that's 2 equations. So you'd have y is 5 halves plus 7 halves, or y is 5 halves minus 7 halves. Because these should all have, 2 answers since it's quadratic. You've got a squared term. So 5 halves plus 7 halves gives us 5 and 7 is 12 divided by 2 is 6. And 5 halves minus 7 halves, 5 minus 7 is negative 2 divided by 2 is negative 1. So there's your 2 answers, and you can check this and it will work. So for completing the square, generally the most confusing part is this part here. But that's, like I said, that's why I write down, take whatever is in front of your linear term, the term to the first degree. If it's a negative, you're going to write your variable minus, because it goes in there. So -5/2, so minus whatever this is all squared, or if it's a positive, it'll be a plus. So that's usually, if anybody messes up, that's where it is that they mess up. And so for the next one, we have b squared minus 6b is equal to 72. So step 1 is to make sure your leading coefficient is a 1. So that's done. We have just b squared, so that's already done for us. Step 2 is get the right hand side, the constant term on the right hand side, not 0. Well, that's already done for us as well. So we can start with step 3. So we're going to have b squared minus 6b plus, take whatever in front of your linear term. So we've got -6 divided by 2 and square it. And then it's equal to 72. And remember, if you add it to the left, you have to also add it to the right. Now you can write it down as a 3. 6 divided by 2 is -3 if you want to. I just write it down this way so you don't get confused. So step 4 is we're going to write this as a square. So we've completed the square. So that means we take this and we slide it into this spot. So it's a negative, so you're going to have a minus. 6 divided by 2 is 3, so if you want to go ahead and make it a 3, b minus 3 squared is equal to 72 plus 3 squared, or -3 squared is 9. And again, you can check this. If you multiply b minus 3 times b minus 3, you're going to get b squared minus 6b plus 9. So 72 plus 9 is 81. So step 5 is take the square root of both sides to get rid of the square. But you have to remember to do the square root, plus or minus the square root on the right. And the square root of 81 is 9, so plus or minus 9. Step 6 is to solve for your variable. So we've got b is equal to, if we add 3 to both sides, 3 plus or minus 9. Oops. I didn't mean to write the square root again. 3 plus or minus 9. So we have either b is 3 plus 9, which is 12, or b is 3 minus 9, which is -6. And 7, if you check, they both work. If you plug a 12 in up here, it will work, and if you plug a -6 in up here, it will work. And then for our last one, and this I just have example on here because I have a number on the notes that are posted, but I changed the problem, so I just wrote example on here. So step 1 is make sure leading coefficient's 1. So it's not in this case, so we need to divide everything by 4. So we'll divide each piece by 4 because we need to make this a 1. So we're going to have b squared. 8 divided by 4 is 2b. And 16 divided by 4 is 4. Step 2, make sure the right hand side is equal to your constant term, not 0 there. So step 2 is already done for us. We don't have to move anything. It would be equal to 0 if you didn't have a constant term, by the way, but if you have a constant term, it has to be on the right hand side. It can't be over here on the left to do completing the square. Step 3, we're going to divide this in half and square it and add it to both sides. So we're going to have b squared plus 2b plus 2 divided by 2 squared. And if we add it to the left, we have to also add it to the right. So that way when we factor and write this as a square, we're going to have b, and then this goes into this spot. 2 divided by 2 is 1, so and it's positive, so we're going to have b plus 1 squared is equal to 4, and 2 divided by 2 is 1, 1 squared is 1, so 4 plus 1. So 4 plus 1 is 5. Then we're going to take the square root of both sides. So if we take the square root, we get b plus 1 is equal to plus or minus. You have to remember to do plus or minus on the right. Square root of 5. Solve for b. We've got b is, if we subtract 1, is equal to negative 1 plus or minus square root of 5. And you can leave your answer in that form. You don't have to do a decimal, it's fine. And you can check this still. If you check it, excuse me, it's obviously not as easy to check with the radical in there, but it will check if you want to check it. But and the reason we have completing the square, like I said, it's generally everybody's least favorite method. It's not the most fun method to do, but it gives you the quadratic formula. So in case you've never seen it before, so you know why completing the square is round. So this is your typical quadratic. So a, b, and c are your numbers, and you got x squared and x. So the step 1, if I keep numbering these like I have been, step 1 is you got to make this leading coefficient 1. So we're going to divide everything by a. 0 divided by a is just 0. Step 2 is you move your constant to the right. So we would have, these are gone, so we would have x squared plus b divided by a times x is equal to, if we take this over, negative c divided by a. Step 3 is to take half of this and square it. Let me go over here and do that in just a second. You would have, if you do b divided by a divided by 2, well, remember this is division, so that's the same thing as b divided by a. If we switch it to multiplication, this is 2 over 1, so you multiply by a half, which is true. Dividing by 2 and multiplying by the half are equivalent, and so this is b times 1 is b, and a times 2 is 2a. So b over 2a is what that would simplify down to, instead of writing it as b over a over 2. So we would have b over 2a squared, and if we add it to the left, you have to also add it to the right. Okay, then we're going to write it as a perfect square here. So you're going to have x plus, this goes into this slot, so x plus b over 2a, all squared, so same thing, that goes there, is equal to negative c over a, and then b squared is b squared, 2 squared is 4, and a squared is a squared. If we go ahead and put all that, instead of writing it as a square, if we go ahead and square everything. Which means this here, if we combine these, the common denominator here is 4a squared. So this has an a, it needs a 4, so we're going to multiply by a 4, and we've got 1a, we need one more. So 4a on top and 4a on bottom. So you're going to be left with, so this is just manipulation and simplifying. So we've got x plus b over 2a squared is equal to there's a negative 4ac plus b squared all over 4a squared, because that was our common denominator. And you can see quadratic formula, because that's our next section, so that's why I'm doing this. Quadratic formula is b squared minus 4ac, that's in there. So if we write b squared first, that's what we would have. So step 5 is take the square root of both sides. So we've got x plus b over 2a is equal to plus or minus the square root of, I'm going to switch this, I'm going to write this first, I'm going to write b squared minus 4ac instead of writing negative 4ac plus b squared, doesn't matter, you can do it either way, all over 4a squared. And I can reduce this here, 4a squared, the square root of 4 is 2, and the square root of a squared is a, so I've got, I'm going to have plus or minus the square root of b squared minus 4ac divided by, like I said, that square root of 4a squared is 2a. And step 6 is I can solve for x. Subtract my b over 2a, so I'm going to have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Well, they have a common denominator, so I can write them as 1. I've got negative b plus or minus the square root of b squared minus 4ac all over 2a, which is what you should recognize as the quadratic formula. And if I'd have thought about it, I would have done it at the beginning of the quadratic formula section instead of right there. But that's okay. So the next section, the next video, has us solving equations using the quadratic formula. Well, the quadratic formula you can derive by completing the square. So like I said, everybody doesn't like that method, but it does give us the quadratic formula, which is a little bit easier than completing the square.